all, welcome to part 16 of the Metasploit Mega Primer. First of all, sorry for the long delay between part 15 and part 16. I was really very busy with work and I was also a bit sick, and everything coming together, I really could not find any time. Anyway, I'll try to roll out a lot more videos in the coming days. So thank you for all your comments. In this video, we will look and understand the pass the hash attack. Now before we begin with understanding pass the hash attack, it is important to first understand how Windows passwords actually work. So whenever a user supplies a password, the password goes through two algorithms, hashing algorithms, one called the LAN manager hashing, which uses the DES algorithm, and the other, which is the NT-LAN manager hashing, which uses the MD4 algorithm. Now both these hashes are taken and concatenated along with the RID and the username and is stored in the SAM file, which contains the different usernames, passwords, etc. Now this is a sample of the SAM file. In previous videos, we have used the hashdump command to get all of these details from the SAM file. Now, what is one major vulnerability in Windows hashing? The major vulnerability is that there is no salt used while these hashings go on. What is meant by that? Well, in cryptography, a salt is actually used so that the salt and the password combination generally gives different hashes for different salts, even though the password itself remains the same. Now in this case, what happens is, as there is no salt, the same user supplied password across different machines always hashes to the exact same LM and NT LM2 hash. Right? Because of this, let's say if I use the password Vivek on machine A, the hash which you will see will be identical to the if I use the same password Vivek probably on another machine. So this is why fundamentally pass the hash attack actually works, because if you think about it, given a password, it will always have only one possible hash on Windows systems. Okay, so now what is pass the hash attack? Well, during normal authentication, whenever a user tries to access a resource on a remote computer on the same network, the remote computer first sends an authentication challenge. The user supplies his username password on his local machine, which gets hashed and is sent to the server. If the hash matches the expected value for that username, then the user is allowed access to whatever resource he has requested for if he has the proper authorization. This is how normal authentication works on a Windows network. Well, pass the hash does just one small modification. See, if you think about it, because after the user enters his username and password, it is hashed. In case of pass the hash, what happens is the user attempts to gain access to a resource and also has access to the hash for a given username. Now this he may have stolen from some other computer. So instead of having to enter a username and password and the password getting hashed, in this case the user actually uses the username and the hash which he has stolen from some other computer on the same network and sends it directly to the server. Now, as we mentioned, because for a given password the hash always remains the same, if the hashes were stolen from a reliable resource on the network, then the hashes will match on the server, and thus the server will grant access to the resource requested by the user. Right? So before we move on to how the pass the hash is used in Metasploit, You'll also have to understand a little bit about a protocol called server message block, or SMB. SMB or CIFS, which is what you would call the Windows version, is a way to share resources over a network. Now, SMB is typically used to provide access to file and directory shares, in which if a user has proper authorization, then he can copy files, download files, etc. Access to shared printers, and most importantly, access to the service control manager, using which remote services can be created, started, stopped, deleted, etc. Now, SMB typically uses either one of two techniques as the transport layer. The first is TCP/IP over port 445, which is what is more prevalent. It can also use NBT on port 139, right? So, what is the Metasploit pass the hash attack? Well, the original idea was actually taken from a tool called PSExec, created by Mark Russinovich of sysinternals. Now, PSExec was actually a remote administration tool using which an admin could actually interact with a program running on the remote system, right? Now, the Metasploit PSExec auxiliary module basically derives all of its internal core from the PSExec tool. So how exactly does the Metasploit PSExec auxiliary module work? Well, the whole idea is to create a Metapreter session on a remote machine for which you already have a valid username and hash combination. The Metapreter session is created by first uploading a service exe file on the remote system, and then using the service control manager access over the MSRPC interface, and then using all of this to create a Metapreter session with the remote computer. Now let's go ahead and demonstrate this using an actual demo. So we have two victims here. The first one is a domain controller, and the other one is a Windows XP machine, right? So what we will do is we will first use a client-side exploit to break into the domain controller, then steal the hashes, and then using that we will break into the Windows XP machine. So let's go to our Metasploit console. So we are running backtrack and we are connected to this instance using this Metasploit console, right? So we launch our client-side exploit. We'll basically wait for the whole server to start running. We've used this specific exploit a number of times, so I'm very sure all of you are familiar with what is happening. If not, please look at previous videos. In the meantime, let me actually bring up Firefox, IE, and now let me type in the IP address for the Metasploit system. So if you notice, our client-side exploit has already started trying out various vulnerabilities on Microsoft Internet Explorer. We'll probably have to wait a bit before the exploit actually works. Right, so right now we are trying various possibilities. Okay, so looks like we've had some success and we have a Metapreter session. Now, very soon this session would be migrated away to a new process just to ensure that if IE crashes, we are still fine. I think the migration is almost done. Yes, it's done. Let's connect to this Metapreter session. So the first thing we actually go ahead and do is dump the hashes. Right? Awesome. So these are the hashes in the remote system. Now, in the pass the hash attack, what we can actually do is use these hashes and authenticate to remote systems, right? So for example, now we are trying to break in into 56.101 using these hashes. So let me background this MetaPreta session and actually figure out where the PS exec module is. It's an auxiliary module. Okay, so let's go ahead and let's go ahead and use this. Let's look at the various options we have. So the remote host is 56.101. Now here is where it gets interesting. The SMB user, we'd actually go ahead and give it administrator. Note that it's not necessary that you would have an admin account on the remote system. We could in that case try out other combinations as well. As the password, what we do is we'll go ahead and give the entire hash. Right? Now let's go ahead and set a payload. Nothing could be better than a MetaPreta reverse shell. I think we'll have to go ahead and set the L host now, which is the hacker machine, which is us. And now let's go ahead and exploit this remote system. So if you notice, basically we are connected to 102, which is the Windows XP system. And right now we are using the pass the hash attack. So first we authenticated as user administrator, which has succeeded. Then we are uploading this exe file, which is actually nothing but a service file. And then we go ahead and get access to the svcctl, which is nothing but an interface to MSRPC services. Then we go ahead and create a new service which we associated with this exe and actually start that service. Using that, we actually go ahead and create a MetaPreta session. Right? Awesome. So if you look at who we are the system authority on the remote system. So this is what typically pass the hash attack is used for, which is to break into other systems and actually get command access. However, you can use it for a lot of other purposes, one of which is to connect to the remote shares of the system, download files and upload files. So Metasploit has a fair bit of utilities for SMB. So let's go ahead and look at one of the scanner utilities. So we'll go ahead and use the enum shares scanner auxiliary module. Right, so in this case the R hosts is actually going to be our remote Windows XP box. The SMB user is going to be administrator, and the SMB password is actually going to be what we stole from a previous session. Right? And now we can go ahead and run this to look at the remote shares. So if you notice, just because we have admin access, we can see the IPC dollar, the admin dollar, etc., and the C dollar, which is the entire C drive or the default shares. Right? Now using other techniques, we can actually connect to these shares, download and upload arbitrary files. I leave all of that as an exercise to you. Coming back, so the basic idea, if you were to do a quick recap, is because of the issue that there is no salting used in Windows hashing, it is possible to use the hash as is to authenticate to a remote system. Once you're authenticated, you'll basically have all the authorization which the user you have authenticated as has. Typically, this is used to upload and download files from the remote system and to have access to the printer. But Mark Rasunovich came up with this interesting way in which you could upload a file, run it as a service, and Metasploit people modified that once that file runs, it actually creates a Metaprinter session on the remote computer, right? So this is what pass the hash attack is, and this brings us to end of part 16. Hope you enjoyed this. Please leave your comments behind. That is what, as I've always told you, keeps me going. Hopefully I'll hear back from you and I'll keep uploading other new videos. Thank you very much. Have fun. Bye-bye.